Today we're going to take the work we did yesterday with verifying trig identities and take it a step further with a little bit more complicated identities and talk about some strategies on how you can approach these. So if we look at example 1, part A, we see the left side is just massive. It has a lot going on, and on the right side it's supposed to reduce down to cosecant squared of x. So what we need to do is figure out how can we get this condensed in order to get it down to that cosecant squared. Now, while I'm looking at this, a couple of things that I notice is that if I were to distribute this, I get cosecant times sine, which is going to be equal to 1 because cosecant is 1 over sine. So I know that will cancel out. If I look at my second fraction here, my fraction here, and I split this up into two fractions, that gives me another sine over sine, which is 1. And then here, cosine over sine is cotangent, and I have a cotangent right here. So whenever you're struggling and you're not sure what to do, that's one thing to look for is, can I split up any fractions? Can I, if I switch things to sine and cosine, does that help with anything? And then see what happens, because even if your original method doesn't yield the correct answer, maybe doing that triggered something else in your mind to approach secondly. So I'm going to distribute this cosecant, so I get cosecant squared x minus, and like I was saying, if we multiply cosecant x times sine x, which will reduce to 1, plus sine x over sine x minus cosine x over sine x plus cotangent x. All right, so now we have cosecant squared x minus, like I said, cosecant, because it's 1 over sine times sine, that gives you -1. Then sine over sine, that's 1. And then cosine over sine is cotangent, so minus cotangent x plus cotangent x. Well, now you can see we have -1 plus 1, those cancel. And negative cotangent plus cotangent, those cancel as well. So now we are left with cosecant squared x, which is what we wanted up here. So we verified that identity. And again, it looked way more complicated than what we were doing, but once we changed some things into sines and cosines and distributed, breaking up the fractions, it yielded a little bit of a simpler expression. Now, letter B over here, we have two fractions, and it's supposed to equal secant and cosecant, which I know is 1 over cosine and times 1 over sine. So I know that's where I'm going to be heading. I have two fractions already that I need to subtract, and one has a denominator of sine and one has a denominator of cosine. Well, if I know that I'm trying to get secant and cosecant, which is 1 over cosine times 1 over sine, if I multiply the first one by cosine over cosine and the second one by sine over sine, my denominator has the cosine and sine that I'm looking for to get my final answer of secant and cosecant. So we distribute the numerator. So that's going to be cosine theta times sine theta plus cosine squared theta minus, and distribute this sign. Okay, so we have minus, I'm going to put these in parentheses, cosine theta sine theta minus sine squared theta all over our common denominator of cosine theta times sine theta. Now remember, because there's I'd use parentheses because there's a negative sign right there, so that I remember that the negative goes to both things. So now I have cosine theta sine theta plus cosine squared theta minus cosine theta sine theta plus sine squared theta, all over my common denominator of cosine theta times sine theta. Well, now if we have this and this are going to cancel, because we have positive cosine sine and then we have negative cosine sine. So that gives us cosine squared theta plus sine squared theta over cosine theta times sine theta. And cosine squared plus sine squared is 1. So now we have 1 over cosine theta times sine theta, which earlier, when I started this problem, I said, hey, I need to get secant and cosecant. I said that's the same as 1 over cosine times 1 over sine. So yeah, we have now 1 over cosine, which is secant, and I have 1 over sine, which is cosecant, and that's what I was trying to get at from the beginning, so I verified that identity. All right, now let's look at letter C. So we have cosecant to the fourth minus cotangent to the fourth equals 2 cosecant squared x minus 1. So that left side is a bit more complicated, and I noticed that I have to get cosecant squared. So I have to go from fourth power down to second power. Well, this is a difference of squares, because I have two things being squared with a subtraction sign between them. So I have cosecant squared x minus cotangent squared x times cosecant squared x plus cotangent squared x. That's my difference of two squares. So now I have to use identities to change this. And again, I know I'm trying to get cosecant squared, so I'm going to change my cotangents instead of my cosecants. Now, cotangent is equal to cosecant squared minus 1, so I'm going to change both of those. So we have cosecant squared x minus cosecant squared minus 1. Now notice I put parentheses around the cosecant squared minus 1 because this negative sign will have to be distributed in. Normally I don't like to do this, but I have to get rid of my cotangents into cosecants, so yeah, we have to distribute this negative for that problem because it's minus cotangent squared, and cotangent is equal to cosecant squared minus 1. So that's why we have that. That's why we have to have the parenthesis there. Oops. Now I'm going to change the other one. So then I have cosecant squared x plus cosecant squared x minus 1. So first I'm going to distribute that negative. So I have cosecant squared x minus cosecant squared x plus 1 times, I can combine these like terms, so it's going to be 2 cosecant squared x minus 1. And we're starting to see how this is going to form. Like if you look at this part right here, that's exactly what we need. So that means the left side is the first parenthesis is going to have to cancel out somehow. Well, positive cosecant squared and negative cosecant squared, that's 0. And then I'm left with 1 times 2 cosecant squared x minus 1. Well, 1 times anything is just what we started out with, which is 2 cosecant squared x minus 1. We verified that identity. So we have to look at what we're given, and we then have to look at where we're going. What do we need to get? Now, letter D, we have secant squared x over cotangent x minus tangent to the third power x equals tangent to the first. So again, I know at some point my squared terms have to cancel out at some point. So I'm going to rewrite this. 1 over cotangent is the same as tangent. So for this problem, I'll write it out. So I'm going to And I'm not really going to switch these to sine and cosines because I know in the end I want just tangent. So 1 over cotangent is tangent. So tangent x. Whoops. And secant is 1 plus tangent squared. So I'm going to make that change. So I use the identity there. Now I can distribute this tangent. So now I have tangent to the first plus tangent to the third minus tangent to the third x. And you can see that these are going to cancel. So I'm left with just tangent x, which equals what we're trying to get. And we verified that identity. There are other ways that you could have done this problem. You could have split up you could have done the identity first, the secant squared identity, and then split that up into 2 separate fractions. But I thought that this was the most efficient method. And I know that's what is one of the confusing things about this, is that there's no right or wrong way to do these problems. There's just ways that are more efficient than others. Now, this problem, we have sine cubed x plus cosine cubed x over sine x plus cosine x equals 1 minus sine x cosine x. So we're going to work on the left side. And that left side, the numerator, this is a sum of cubes. So we're going to write this out using the sum of cubes formula. A cubed plus b cubed is equal to ab times a squared, minus ab plus b squared. So that, again, that's the rule for the sum of cubes. And our a value is sine, and our b value is cosine. So let's make this, let's factor this using that. So a plus b. So sine x plus cosine x times sine squared x minus sine x cosine x plus b squared, so plus cosine squared x, all over sine x plus cosine x. And I think you can see where this is going. We're going to cancel these off. And I'm going to rearrange so that the sine squared and cosine squared are next to each other, just so you can see what we're doing. So sine squared x plus cosine squared x, and I can do that because it's addition. Well, we know that sine squared plus cosine squared is 1, so it's 1 minus sine x times cosine x, which is equal to the right side of that equation. So we verified that identity. So yeah, we need to be mindful of those special factoring patterns. I know we haven't used the sum or difference of cubes in a while, but just be mindful and have that formula handy. Right, on the next page, it says use the cofunction identities to evaluate the expression without a calculator. So we're looking at this, and it's a bunch of sine squareds, but we also know that the two angles, the cofunction identities, says like the sine of 73 degrees is equal to the cosine of 17 degrees, because those two angles add up to 90 degrees. 73 plus 17 equals 90. So we're going to use that for this problem. Now, we don't have to change there's no rule that says, oh, I have to have change all my signs. So we're going to use this to change some of these sines into cosines of the corresponding angle. So instead of, I notice 43 plus 47 is equal to 90 degrees. So instead of writing it as the sine of 43 degrees, I can write it as the cosine squared of 47 degrees. And then instead of sine of 73 degrees, we know that this would be the cosine of 17 degrees, using those cofunctions, because 17 and 73 add up to 90 degrees. So then we can rearrange this. So I'm going to have cosine squared of 47 degrees plus sine squared 47 degrees plus sine squared of 17 degrees plus cosine squared 17 degrees. This is equal to 1 because it's cosine squared plus sine squared of the same angle. This is also equal to 1 because it's, again, sine squared plus cosine squared of the same angle. So we have 1 plus 1, which is 2. So that's the value of these cofunction identities. All right, now our last example, we're going to be using the power trig functions to verify this identity. So we have tangent to the fourth equals tangent squared times secant squared minus tangent squared. So I'm going to work on the right side because there's more stuff there, and I need to get tangent to the fourth power. So if I factor out a tangent squared x, that's going to leave me secant squared x minus 1. Well, one of our identities says that this is equal to tangent squared. So tangent squared x times tangent squared x, well, that equals tangent to the fourth, which is what we're trying to get anyway. So we verified that identity rather quickly. As you do more of these, you will get faster and better at them. So thanks for watching. Make sure to like the video and subscribe.